we have understood what is laws of chemical combination, and under that I hope you have understood even what is law of conservation of mass and law of constant proportion, as well as John Dalton's atomic theory. Now we have understood all matter is made up of a tiny particle called atom. So what is an atom? So let us see what is an atom. An atom is the building block. It is the building blocks of an atom is the building block of all the matter. All the matter, when we say all the matter, it includes elements, compounds and mixture. Elements, compounds and mixtures. You take any of the matter, whether it is compound, mixture or an element, they're all made up of atom. So let us take one example for mixture. So let us see mixture. So what is one good example for mixture we can give is air. So what is air made up of? Air consists of, it consists of carbon dioxide, it has oxygen and it has nitrogen as well as water vapor. So when we closely observe, what we see is the mixture, that is air which is mixture, has several compounds in it as well as elements. That is, we see that the carbon dioxide has carbon and oxygen. Again it is element, right? And oxygen you know, and nitrogen you know, and water is again made up of hydrogen and oxygen. So a mixture also made up of an element, right? Let us talk about compound. What is the compound? Again water is also made up of elements. So what we can say? A matter is made up of an atom. You take any matter for that reason, okay? Whether it is element or compound or mixture, everything is made up of an atom. They are made up of several atoms, okay? Not one or two atoms, okay? Now, what is the size of an atom? How small is an atom? How small is an atom? We cannot see an atom. They are so tiny. Okay. So let us see how small is an atom. Atom is very tiny. We cannot compare the size of an atom with anything because we cannot imagine the size of an atom. If at all you want to make a thin sheet of paper, you can imagine how many millions of atoms are required to make that thin sheet of paper, thin layer of paper. If at all you want to make, you want more than billions of atoms are required to make one sheet of paper. That is the size of the atom. They are so tiny. Now, when they are tiny, when atoms are so tiny, so small, why should we study about them? We have to study about them because just now we learned that all the matter is made up of an atom and they constantly will be influencing us and they have an effect on us. That's why we have to study about an atom. Now, one thing is clear, all the matter is made up of atom, right? So now, how to remember that, how to know which substance is made up of which atom. So now we know elements, right? So elements are made up of an atom and we have so many elements. How to remember those elements? So to remember those elements, what we have to do? We have to learn their symbols. So let us see what is symbol. So what is symbol? Now, when I say platinum, right? What is the symbol of platinum? Right? Pt. Platinum is Pt. And I want to write the symbol for oxygen. So So I write O. Or I want to write the symbol of chlorine. So I write Cl. Okay, who decides all these things? Who gives the symbol for all this element? See, in some I have used only one alphabet, right? One letter from the name of that element. From the name of that element, I have taken one letter. That is oxygen, I have taken O. Now, for chlorine, I have taken two. That is Cl I have taken. And whereas here in platinum, I have taken Pt. Why can't I write this as P? Why can't I write it as C? Okay? These things are not decided by you or me. We have an organization which decides the symbol for various elements. Before that, who started giving symbol of the element? And let us see what is symbol. Symbol is a scientific, it is a brief scientific representation. Okay, it is a brief scientific representation of one atom of that element. Okay, it is the scientific representation. Okay, it is a brief way of representing the name of the element, and we are representing one atom of that element. If I am writing oxygen as O, I am representing the name of oxygen in a very short way, and I am representing one atom of that element. Here again same thing. If I am writing Cl, Cl is a symbol for chlorine. I am representing the name of chlorine in a very short way. Okay, it's a short form of chlorine, and I am representing one atom of that element. So who started giving the symbol? So it was started by John Dalton only. John Dalton only, he proposed the symbol. He was the first one to propose the symbol. He had given a symbol for different elements. See, these are the symbols given by him. Okay, so this is like, pictures kind of thing. Okay, so this is for gold. This was gold, and this is for phosphorus. This was for phosphorus, and this was for gold, and this was for platinum. Okay, and for mercury, he had given like this structure for mercury. Okay, and carbon, he just made it into a dark substance, black color thing, and this was for carbon. Okay, so these were the symbols given by John Dalton. Later on, one more scientist by name Berzelius suggested, instead of going representing pictorially, we can use the letters, alphabet of that particular element, and we can use it as symbol. That's what Berzelius suggested. Nowadays, the modern day system, we are given, the elements are given the symbol by a union called IUPAC. So what is this IUPAC? IUPAC is a international union. It is a international union of pure and applied chemistry. They give the symbol. That is IUPAC, International Union of Pure and Applied Chemistry. They give the symbol for the element. So now let us learn the symbols of few elements. Okay, and we know that when we write the symbol, we take the first alphabet, right? The first letter of that element. For few elements, we take the symbol, that is the first letter. So let us write down that. So first one, so let us take oxygen. So you know the form, you know the symbol for oxygen. So you know nitrogen, hydrogen, carbon, okay, sulfur, phosphorus. So here what we do for these elements, we have taken the first letter. We have taken the first letter and given the symbol. So what is the symbol for oxygen? It is O. Nitrogen, N. Hydrogen, H. C, carbon, S is sulfur, and phosphorus, P. Then, in case of, let us take neon. Okay? Helium, calcium, okay, and barium. So here when we talk about these elements, can we take the first letter? We cannot, because already first letter, that is nitrogen, already we know N is for nitrogen. Again we cannot use N for neon. So what we do? We take the second letter also. So we take the second letter. Okay. Now the symbol for neon. So it is Ne. Always the first letter will be capital letter and the second letter should be the small letter. Next is helium, He. This is calcium and this is barium. Okay. So that is taking the second letter. Then what about chlorine? Okay. Magnesium, manganese, okay, platinum, zinc. Okay, when we look at these elements, we take the letter when the way on which we are stressing. When we pronounce the name of that particular letter, on which letter we are stressing, we will be taking that letter, the first letter, and as well as the letter on which we are stressing. Okay, so chlorine. So chlorine. So we write Cl. Magnesium. So Mg. Manganese, Mn. Platinum, Pt. Zinc, Zn. So we saw now how symbols are given. Symbols are given either by taking the first letter of that name of the element or the second letter, or in some cases when we pronounce on which letter we are stressing. So that will be taken. So whenever we are writing the symbol, care should be taken that first letter should be always in capital and second letter should be in small letter. And there are few elements for which the names have been taken from Latin. So let us see those elements, the Latin name and symbol. Sodium. Sodium, it gets a symbol Na because in Latin it is called natrium. Okay, and potassium is kalium, K. Lead, plumbum, Pb. Copper, cuprum, Cu. Gold, ferrum, Fe. Silver, argentum, Ag. And tin, stannum, Sn, and gold, aurum, Au. So these are the Latin name and their symbol. I hope you have understood so much. Okay.